Hello, we are Team DOS DDoS, and here is a sample demo video of how our application DDoS Protector uses its internal mechanism to predict the percentage DDoS on our client's application. For this demo video, we simulate a DDoS attack on one of our servers and then use our application to predict the percentage DDoS that was occurred. For the demo purpose, we simulate two different attacks, one on a larger scale, one a smaller, to show the difference between the percentage that our application predicts. For the demo, we had two different limitations. One, that the type of DDoS was just a simple GET request on a ping API that the server exposed. This can be extended to a number of different network layer requests or attacks that happen in the real world. Second, that for the demo, we captured the packets using the TCP dump application and later analyzed it using the PCAP file generated. For for the real world application, we would be slowly implementing a real time transfer of packets to our application, which would enable us to monitor the packets in a real time, enabling only secure packets to pass through. So for the packets, these were the two different uh, networks logs which we could accumulate. First, a larger DDoS attack, which we logged around 1000 requests per second, and a smaller one for around 380 requests per second. In the next part of this demo, we would be showing how the different attacks are being represented by different percentage of the DDoS.
In the previous part, we demonstrated that how we collected this TCP data. So we are collecting the packets, and for each packets, we are collecting its timestamps along with the source IP and the destination IP. We are also recording its protocol along with the length of the packet and some other additional info about the packet. Now we will use this packet to analyze whether they are part of a DDoS attack or not. So what we are doing is we are first of all we are dividing these packets into the chunks, and then we are passing each individual chunk to our machine learning model, which is based on the CNN, to classify whether that chunk is a part of DDoS attack or not. And on the basis of the parameters such as the source IP, protocols, and all of these factors, our CNN model try to output a DDoS percentage based on those factors. So on the left side of the screen, you can see the analysis of the small attack. In the small attack, uh, you can see that the most of the DDoS percentage are 0, and some of them are very small like 0.93 and 0.23, all of these things, but most of them are tending to 0%. This is due to the fact that for the small attack we only used a small number of requests per second. It was around 350 or 360 requests per second, which can be a normal user workload. And for the large attack, here you can see that with time it's increasing. Initially it's 12%, then it became 15%, now it's 34%, 35%, and then 34%, and 71%, 82%, and at last it has become 92%. So with time, as the number of requests per second is increasing, our model is correctly predicting that DDoS percentage is increasing. So to better visualize all of this, we have plotted these numbers on a line chart so that we can compare with the number of requests per second. So on the left side of the screen, you can see the line chart. With time, the DDoS percentage is increasing, and similarly, in the request per second graph, you can see that the number of requests per second is continuously increasing on our server. And after some time, the DDoS percentage start decreasing, similar to the number of requests per second. And then again, our DDoS percentage start increasing as the number of packets on our request per second on our server is increasing. So this is consistent with our model. Also, now to do is based analysis to find the management and our tool to that we can provide time protection and recovery against the data system. More details have been provided in the slide. Thank you.